Assalamu alaikum. Welcome everyone. There has been some technical issues in the mic, so we will be starting in a 3 minutes time, 2 to 3 minute time.
हेलो, एक मिनट यार, एक मिनट रुक जाओ। हेलो 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 हेलो, ठीक है बवास? हेलो, कैन यू हेयर मी नाउ? आवाज़ ठीक है? ओके ओके ओके, बस बंद कर दो। Hello everyone, we have started a new webinar series for engineers in Pakistan in which we will be discussing different industrial design and manufacturing issues faced by the industries. Our upcoming webinar topics will include 3D CAD Essentials, which is not basic but give you information at intermediate level. Our other topics will be advanced part modeling, complex assembly design and analysis. We will do some detailed drawings including bill of materials, advanced surface modeling. We will discuss and describe computer-aided manufacturing tools with generation of NC programming, and also we will do some mold designing strategies. And then in our other course, we will discuss sheet metal bending, unbending issues that can be resolved by deformed length calculation method in Solidworks. Moreover, we will cover reverse engineering and 3D inspection topic, which is major requirement in industries today. We will perform live demonstration for you with 3D scanner and practice from generation of point cloud data to 3D model and perform 3D data comparison analysis as well. As it will not be possible for us to cover all of the topics in details, therefore, you can visit our training centers to attend classes for above courses and can get the certifications. I am Mohammad Usama Siddiqui, responsible for technical support in the company. We are Quality Solutions. Our main purpose is to adopt innovative tools in technology throughout the world and introduce them in Pakistan. Alhamdulillah, we are professional in computer-aided designing, computer-aided engineering, computer-aided manufacturing, and having expertise in 3D scanning, reverse engineering, 3D inspections, and 3D documentations as well. By the way, we are fully equipped with both hardware and software. Let's back to the topic. SolidWorks is more than just a CAD, providing complete tool set that helps you to be more efficient and productive in your product. Development through every steps of the design process, it can help you assess the environmental impact of your product. Among all these five distinct of the product line process, we will discuss three distinct, which will be included design tool and create mold and assemblies, simulations tools to the test the design and ensure it is the best it can be. And in last, we will apply tools to assess the environmental impact of your design throughout its product life cycle. All these solutions work together, allow companies to make their product better, faster, and reduce their product cost. Let's take a closer look at these elements, starting with the design tool. Before starting, let me tell you a quick introduction of the machine. Resin bolter is a drilling rig for mechanical rock. It support in underground mines. It drills holes in mines walls and bolt screen to the walls and ceiling to ensure mine safety. The design work will focus on the boom that support the drilling head, and also the resin assay is a manufacturer of boring machine for underground mines. In this workshop, we will work on a 3D CAD assembly of the machine, which is already designed in the software. However, what you are seeing on screen is our agenda. The roadmap will cover following steps, including part designing, part drawing, kit assembly, booms drawings, main boom assembly, simulate, and then we will do some design checks to complete the final design. Let's start with the part design. In this task, we will start from a basic sketch, converting them into 3D model and apply imported part from the library. I hope you can see my screen. In this demonstration, our design work will focus on the bottom that support the drill head. So let's take a closer look. The complete boom design, we need to add some components to connect the hydraulic cylinders to the boom support. This will require we create a knuckle and add some pins and wear components to take the load. To start new part design, click new. And here we will define the part, click OK. Now in the beginning, as we have only these three reference planes, so we will choose one of them and start creating a circle. I will choose the top plane, go to the sketch, or I will click on the right plane and click sketch. Once the top plane is parallel to my screen, I will use mouse gesture within the SolidWorks, which give you easy access to use the tools in your hands. After defining both circle, I will give the dimensions. Our first diameter will be 120 and the second value is 160. 65, sorry. Once I have done, I will proceed my sketch and came out from the sketch. Now on the sketch, you can see it is placed on the top plane. I will simply double click and drag my reference sketch to provide it a protrusion. So as you can see on the screen that it is one-sided protrusion. When I click on M, it will give me the protrusion from the midplane. So I will set the value to, let's say, 127. But this is not an issue. When you are not exactly defining your value, you can double click on your part and give your value. Again, similarly, I will make another cylinder on the front plane. For that, I will choose the other way, like I will click on the front plane. Again, I will go to the sketch, or I will go from the icon above, you can see. Here, I will make again a cylinder. As I already defined you that SolidWorks is a powerful and smart software. It guides you from where you are designing. So now I am horizontal with this cylinder from the mid of the center. I will make two cylinders again. This time I will not give it a value, but I will use an option fully defined sketch. What fully defined sketch is doing that when your sketch are drawn, but it has not provided the values, the fully defined sketch will give you the calculations and all possible values with the cylinders. Calculate. Yes. Again, I'll give it a value of 120, let's say. And this one I will give 65. And last one I will give 160. So my sketch is fully defined. The fully defined sketch means that it has defined all the dimensions which cannot be disturbed when you are doing modifications in the part later. Otherwise, if your sketches are not defined, your after the modification, your reference sketch will be disturbed and your whole assembly or part protrusion will be disturbed as well. Once I have done it, I will click proceed. And again, I will select here and make a protrusion from the center. I want to give it a value of 150 millimeters from the mid of the plane. Now I'm done. Again, I need to make some cuts from the top of the cylinder. So I will select again the top plane and click sketch simply. But I will need some references. To do that, it is better to use hidden lines removed mode. So the profiles inside the circle cannot be appear. If you want to see those profiles, you need to select hidden lines with visible. So the dotted lines representing the hidden profiles inside the circle. So in my case, I will select hidden lines removed. And I will create again a line. In my case, the line for the construction. Construction means that I will use this line as a reference. It cannot be used for protrusion or revolve to the feature. When I go to the mid of this line, the SolidWorks tell me that this point is the middle of this line. So I will click from here and make a vertical line. Let me hide these planes for now. Also, I will make again a center line from the center of the circle to the center of this cylinder. Now I'll create a center rectangle from this cylinder and as you can see that when I go near to this cylinder, the software tell me that both lines are collinear. So I want to fix my this line to this reference of the circle. So I will click here, and for the dimensioning, I will go to the dimension, select the line, and give it a value. One more tool I want to show you during this demonstration. It helps you to sketch in symmetric. What it do is you will draw a sketch on one side and it will automatically mirror on the other side. I'll click on the dynamic mirror entities. For that, the software tell me that please select a sketch line or linear model edge to mirror about. So I will make my center line as a reference. Now, whatever I draw this time, it will be mirrored opposite to this plane. But right now I cannot select any reference because this is the sketch we make in earlier sketches. So what I can do is first I will use convert entities and select this one. So it will automatically be placed on the reference plane we are sketching. Now I will select the line. And create my basic sketch. So you can see here, when I create this line, it is automatically mirrored on the opposite side. I want to make my both lines are parallel. So when I go to the nearest possible parallel, the SolidWorks tells me that in this position, both lines are parallel. I'll click OK. and then done. Let me give the dimension to this one. But right now I have make this protrusion is very small. So let me do it. I will click OK to my sketch. So as you can see on my screen that this sketch is underdefined, meaning that it can be moved or it can be disturbed when you make some modification in your part later. So better to define the value so it will be fixed and will not be disturbed later. I will give it a value. Again, for the values, I will go to the dimension. Give this dimension the angle of 4 degree. This will be 25. And in last, my distance from this reference plane to this vertical plane is 90. As you can see that I am still working in the millimeters, but I want some dimensions which should be selected in centimeters, but automatically converted by the software in millimeters. For that, I will just go to, I will define my numbers, and here in the units, I can select in centimeters, in feet, in inches. What I have defined in inches, for example, if I consider it inches, it will make 90 inches converted into millimeters. But in this case, I will make this one as 90 millimeter and okay. Now you can see on the screen, my sketch is fully defined and it is highlighting in the black. So when I move or select any of the point, it cannot be moved because it is fixed now. When I have done my sketch, I will make a protrusion of this selection only. For that, I have to go to the feature, extrude base, or I will simply select this sketch. But in this case, I want to make a selection of the region inside this sketch. So what I will do is I will go near to the sketch and select this region. So SolidWorks smartly identify the region and present me the results, the outcomes. I will give this value of from the midplane, the option I selected. There are a lot of options we can use like through all, up to the next, up to vertex or surface. But for my case, I will select midplane and define the value. Make sure to check on the merge result. So what SolidWorks do is it will merge all three protrusions to one body. If I will not check, it will consider these three bodies as individual. I'll click OK. Let me show you in shaded view. Now my part is almost ready. We just need to make some cuts. Again, for the cut, I will select my sketch and go to the extrude cut. In the extrude cut, I will select this rectangular face and select through all both sides, which means that if there is any solid on both sides, this rectangle will cut them. Click OK. Now two more things are remaining, that this body should not be inside. So what I will do is I will select these faces, go to surfaces, delete faces, make sure to make a selection, delete and patch. What it will do, it will delete these surfaces as well and make a patch for this body. Now I will apply fillets on my body. I will select the internal profile. Now here, after selection of the fillet of the edge, my software tells me that these are the possibilities we can choose during applying the fillet. So connect to the start virtual loops. It is already highlighting in the pink. Internal to feature, connected edges, and you can see that it is giving you the value 9 edges as well. So in my case, I will select all concave 7 edges and give the value of 7 millimeters. So now my part is ready, but there is missing a part inside this one. To do that, in this case, actually, I don't have the reference of that part. It is a solid model. So what we need to do that, we will import that CAD data and merge with this solid body. We'll go to the design library. And here we will select grease fitting and drag and drop simply to the surface. Now I have made 4 configuration of this grease fitting port. So we can check one of them and define the reference of the top. Also, to positioning this greasing fit port, I can give it a value 125 by 2 and the angle of 60 degrees. Done. Now my part is ready, and what we have learned in this example, as you can see, that SolidWorks has very simple, intuitive workflow, and it also has easy to learn and use access, heads up user interface, interactive design tool, and quick use of standard content. Now at this point, I would like to ask a question from you. Can you see on my screen? What engineering discipline you belong to? Please answer. We will have time of the 30 seconds. Almost 50% of the people answer already. We can wait for a few seconds as well. Okay. So right now the people join us. Maximum the people is in civil engineering. Some of them belongs to the mechanical engineering. We have joined by the electrical engineers, electronics engineers, mechatronics engineers, aeronautical engineers, and others. Let's get back to the topic. Our next practice describe how to create quick drawing of the knuckle part we have created. In this task, we will set drawing views of sheets, create section views, and later we will add details as well as we will define dimensions. Let's have a look. To create a drawing, I will click OK on New, make drawing for part assembly. Let me do it for the other one. I will select the sheet size, OK. And now I am in the drawing sheet. To start creating a drawing, I will use the front view, just simply drag and drop to the sheet. And with the reference of my front view, it displays me its top view. I want it as well, and the right view. I also want its isometric view to add in this drawing sheet. Let me delete the central line from the isometric view. And make it a shaded with edges reference. To define the details of this whole, we can make selections. And for section, we will go to the view layout, make section, and just go near to the center of this cylinder. But I want to make a cut off in the vertical, so I will click on the tab. It will be converted. Let me do it again. Section view, tab, now my grease port details we can see on this section view. And if I want to add detail views as well, I just click on the detail view, go near to this reference and create a circle. It extracts the details and mention it as a reference named F. Now we are almost done with a quick review of the drawings. Only remaining are the dimensions. For that, we will do a quick dimensioning. I'll click on the model items. And here in the selection, I will select entire model and click OK. So SolidWorks created all possible dimensions, not all possible, but it defines all dimension values which I give during my sketch. So we can adjust these dimensions by simply dragging and drop. And now our drawings are completed. So what you have learned in this task, automatic to create automatic views and dimension placement, getting production quality details drawings, and avoid drawing errors. Our next stage is to work with the sub-assemblies component. In this task, we will add multiple components from library like bushes, flanges, washers, and bolts, creating explode views and make it detailed drawing in next stage. Let's do this. We all start by leveraging our design library to select the flange bushes and drag and drop it into this assembly. As it's dragged over the hole automatically seats itself in a hole through the use of smart mates, we will add another bushing to the bottom as well. Notice that there is a star on these bushes. This indicates that this is a smart component. It contains smart features. Clicking the star in search the smart feature, if you can tell by the dimensioning display on the screen, and if we can take a closer look, we can see that these features were actually added to the knuckle part to which it was assembled. We can dig deeper by using the section tools and see that the bore fillet and chamfers were added to our part. Let's add the smart features for the other bushes. And just like that, we define the proper bore for the bush. Next, we could add the grease fitting by snapping it into position as well. We need to add a pin to assembly for models that are not in our design library. We can leverage software Solidworks search to find items anywhere on our computer. Send it with all the model with expander in their names. Or describe and drag and drop the proper model into our assembly. This expander pin was created in two sizes. For this location, we will choose 220 millimeters length pin. SolidWorks automatically places the pins and asks us to verify that we want a concentric mate. The pin is positioned properly in the hole, but we can still move it up and down. So we could measure this pin and do some mates to position it with the distance mate, but a better way to letter SolidWorks to do this with mate. This advanced mate takes the select faces and center them to each other. It was easy and I didn't even have to get out my calculator. Next, we will do search in workplace for wear plate at the top of the knuckle. Adding another to the bottom is easiest, holding the control key and drag and dropping a copy of the wear plate from the top of the bottom. The pin needs to be added to the hole on the left as well. So just drag and drop this one from the feature manager and snap it into position with concentric mate. Using with mate again, we consider this one in no time at all. But this stage is too long for this application, so we will leverage the configuration of the pin assembly and use 150mm version. And our assembly is completed. No great way to communicate how to simply goes together is with an exploded view. And this is simply in SolidWorks. Let's grab these three components, just drag and drop them. SolidWorks automatically spaces them, saving me the time of having to do them individually. We will do the same on the other side, this time selecting the pin as well. Let's explode the grease fitting. And try to line up within own axis. The sub-assembly already has been exploded information. We can leverage these explode steps to save time. Finally, let's explore the wear plates and bushing using the same technique. It's look pretty good, by the way. Now we'll save the assembly and make an assembly drawing. क्या हुआ? वो आ रहा है, वाईफाई आ रहा है। So you have seen an intelligent use of standard content with simple placement and positioning of component come from library. All is done with the help of innovative productivity tools of SolidWorks. Now again, I have a question for you. What parametric CAD software do you use? Please remember we have 45 seconds of time. Thank you for your answer. So it looks like almost 45% of the people are using SolidWorks and others are using other softwares. 37% of the people are using other softwares. Unigraphics only 2% people, Creo only 10%, Inverter only 2%, and Katia only 5%. So looks like that SolidWorks have a good market in engineering field. Let's back to the topic. In our next task of bill of material drawing, we will convert our exploded subassembly into drawings and define bill of materials, adding some ballooning as well. Just as with the part drawing, the view palette is automatically populated with views that we can simply drag on the drawing sheets. Let's leverage the explode step we just created here on the drawing and add some additional views. SolidWorks automatically scales the drawing to accept the views placed on it. But it can be easily changed. Let's make this quarter scale that looks better. No assembly drawing is completed without a bill of material. SolidWorks make quick work of this by extracting all the components and the quantities and description on buildings material. Without balloons and the audible in tool make this a snap. On your screen you can see the details of all components within this assembly. We can position the balloons to our liking or choose alternate balloons layout for this. For this, we will place the balloons on the left and choose to balloon all instances. These balloons are added to the view, then placed on a magnetic line. Magnetic line can be used for positioning and additional magnetic lines can also be added to the drawing. We can grab some of the balloons and snap them under this new line to make the drawing easier to read. We will do a little cleanup work on some of the balloons. Let's change this view actually to the shaded and finish the drawing by adding critical dimensions, like distances between the centers, so by selecting multiple critical requirements in the drawings, we can define the dimensions. Our drawing is now complete. Let's save drawing and assemble the kit to the bot to the boom assembly. Since we have passed through a consistent workflow, which leveraging us to get out automatic bill of material and item ballooning quickly, and enable us to define comprehensive assembly views easily. After completion of our sub-assembly, we will import our components to the main boom assembly and define mates to reposition our components in last. We will check whole assembly movements actually. To do that, we need to drop these kits into the assembly which we make in our earlier task. We will make a copy of that. Since we have positioned them, they are free to move around. You can simply position them by dragging the wear plate of the kit assembly as well. And Smart made it into the hole in support bracket. This position the kit on along the axis of the hole, but it can still rotate for now. Let me do this first. As we move the boom, you can see that our assembly behave exactly as we want. Our steel knuckle look a bit out of a place and could use some paint to do this. We will simply copy the appearance of the support bracket and paste it on the knuckle. Looks pretty good. You can see that all of our mates are defined and the movement of our parts are working according to the reference mates. I believe you agree that how it is easy to use assembly relationships in SolidWorks. Also dynamic assembly motion define visualize analysis to identify component connections. Please answer the question, what feature of CAD modeling you often use? Is it solid part modeling, surface part modeling, or sheet metal modeling? Thank you for answering the questions. We should move to our next stage, which is simulation. In simulation tasks today, we will perform load analysis on knuckle kit assembly to see if it can stay with required load that machine must survive in real situation. We will check stress surface displacement as well after stress and check factor of safety. The 125 millimeter bore hydraulic cylinder put out a great deal of force in order to validate our design. We should perform a simulation on our knuckle kit to see if they can withstand the load. To do that, we will leverage SolidWorks simulation and also these bolts and washers. This can be easily accomplished with the selection tool as well. We may also want to add a rod in to the assembly to better define the load transfer with a quick search. We can find this part and add it to the assembly. Let's center rod I up with the width mate and then located it what will probably be the most extreme loading situation. We'll click on the new steady, define static, click OK. On the feature, we will click fixed geometry and define the references. Notice that when I animate between these two faces, SolidWorks let me do it again. I will apply a force. And again run the study. Now SolidWorks itself solving the problem and give you a stress in terms of stress analysis, displacement analysis, and factor of safeties. That's it, and we are ready to run the simulation, which is completed. Establishes the contact between the parts and run the analysis with the fastest solver in the industry. We are presented with the result in no time at all. Alerts on the part correspond to the stress values listed on the right. For knuckle, we want to have a minimum factor safety of 2, so we can change our chart and disregard any values above safe for. We can see that there are areas in our knuckle that do not meet our requirement of 2 for the factor of safety. So we are gonna need to make some changes. With SolidWorks, there is no need to start over. Just edit and make some changes that will strengthen the area of concern. Here we will modify the fillets, apply the modifications, and automatically when the part is updated, the whole assembly and the drawings are also updated. Let's do it again, solving and see the results. So you can see that improve in the stresses and also the factor of safeties. Select suppressed and set to resolve. So as you can see that we can edit and resolve our issue in the software. And here all the views are updated in the drawing as well. Here I will measure the dimension. Before it was 30 radius, now it is, before it was 10 millimeter, now it is 30. So all the linked feature, whether it is related with the drawing, with the part, with the assembly, will be automatically updated. We will not require this one. So let's delete this and define the section again. I want the section from this side. And give it the dimension. As you can see that we already defined the tolerances in the values. And reposition the dimension. I want to show this dimension from the other view to this view. So I will just select and drag and drop to the other view. For this view, I want to show this radius inside, click inside and OK. Now we have done and let's save. So in this task, what we have done to import the knuckle body, which is actually a sub component of the assembly. We perform simulation, static analysis on the knuckle, and then After seeing the results, we modified our parts which did not impact on our assembly or drawing, that is automatically updated. After that, we again run the simulations and check the factor of safety, which is now fine. So the simulation in SolidWorks is for both engineers and designers, which promote them to interactive design and validate them while remain in the same interface that help them to understand how to make a better design. Let me open a polling booth. We have two more questions for you. How you find assembly modeling in SolidWorks? 20 seconds are left. Thank you for voting. Now we are almost done with our process. We have performed the part design, drawings, kit assembly. We discussed already the boom drawings, the main boom assembly, and perform simulation. In last, we would like to check visually our design and use motion analysis tools to check if there is any correspondence between the components. Let's do a quick design check. You will notice that the knuckle changes are reflected here as well, as everything stays up to date. One of the most powerful benefits of design and 3D is interference detection, which can identify clashes before any part are built. SolidWorks interference detection is extremely fast and powerful. We can run it interference detection on this 500 of assembly in no time at all. And sure enough, we have none. But most simply, such as this one, have moving part. As you can see on the results that there is no interaction between the parts, but we would like to do collision detection as well when we are dragging our part. As you can see that right now, the part seems okay and there is no collision while moving our assembly. So if you move your part through the range of the motion, SolidWorks will find and identify any clashes in the assembly. In current situation, as our design is already completed and there is no issue including in the simulations, as well as we perform the collision detection, and we found there is nothing during the movements. When we perform the collision detection, we mention these factors to highlight faces that we are moving, create a sound if there is a collision between the components, ignore complex surfaces. This time we are trying to figure out the major component study. So as you can see that we have almost done with our part, and here we have completed our demonstration. Our today's topic is complete almost, and I hope this session is informative for you people. I would like to thank you for attention that you people stay with me to the last. Please feel free to write a question if any one of you have, or you can send me an email on mentioned address. In last, I have a question for you. How do you assign the dimension and bill of materials in drafting? Please share with me your experiences. If you are doing it manually or you are doing it by the software which gives you result automatically, or you do both tasks, some manually and automatically. Thank you for answering the question. So most of the people are doing manually and automatically dimensioning with bill of material. Now if you have any question, you can write to me. Let me search in the chat. There's a question from Mr. Sarim. Which CAD software is being used in international design companies? Well, I appreciate your answer, but 60% of the international market is captured by the SolidWorks. When we talk about parametric CAD modeling for detailed drawings, AutoCAD also have a big portion of market, but they mostly being used in civil engineering. I hope you get the answer of question. The second question is, what type of certifications SolidWorks offer? SolidWorks offer 16 different certifications for user actually. It categorized into three levels: the associative, the professional, the expert. These includes 5 associative, 10 professional, and 1 expert. However, in professional, SolidWorks offer certifications on surface modeling, sheet metal, weldments, and mechanical design. Do you provide technical training on the CAD? Yes, we are authorized reseller of the SolidWorks in Pakistan. As I mentioned in my uh, initial slides, so we also provide certificate courses. Hmm? अच्छा, मैं ये तो पढ़ लूं. Another question we have received: what type of simulation SolidWorks offered? It's again asked by the Sarim. SolidWorks offer more than 20 different simulations actually. Depends on your application, what is your requirement. So SolidWorks, which range from static, buckling, drop test, CFD analysis, HVAC, heat transfer, and non-linear analysis, all the topics mostly include within the SolidWorks. Already answered. Another question, can we 3D print the CAD model with the help of SolidWorks? Yes, we can use SolidWorks 3D CAD model for 3D printing, as 3D printer is an additive manufacturing process and rely on layer thickness. In SolidWorks, we can assign the layer thickness and save the part in STL format, which is a 3D printing format. The next question is, can we open other CAD files in the SolidWorks? Yes, obviously. SolidWorks is a smart tool which collaborate with format of other CAD software and help you to open native format of CAD softwares such as Creo, Inventor, CATIA, and Unigraphics. But the feature tree will not be appear for changing already design order. The next question asked by Adnan Shehzad: how much SolidWorks is beneficial to design and draft the mechanical structure design, like plant and multi-story steel frame? So SolidWorks itself include the structural CAD tools for plant designing and story steels can also be, and even the frames can also be designed within the SolidWorks. Even for SolidWorks includes the weldment tools. You can perform the welding analysis between the frames. The question is how to validate simulated results in SolidWorks. The question asked by Mohammad Asad Iqbal. As you know that SolidWorks or any CAD tool design software based on the mathematical calculations and the software includes the standard international standards to follows. As you know that the Dassault System company is the creator of software like CATIA and Creo. So when you are doing the designing within CATIA and perform the surface modeling, as you know that CATIA is highly recognized and the simulation results are verified. The next question asked by Mubashir Mirza, it is easy to move SolidWorks while an organization is using AutoCAD. Yes, SolidWorks has, as I already informed you that SolidWorks has the integration which can directly import the CAD files from Unigraphics, CATIA, AutoCAD, Creo, and other softwares. So you can directly open AutoCAD files into SolidWorks and also can perform modifications on your 2D drawings. And I would like to add information here that SolidWorks includes some customized template as well. So if you have some unique custom templates, you can import within SolidWorks. Actually you have to create within SolidWorks first, and you can reuse it again. The next question is, what is the difference between SolidWorks and Pro software? This question asked by Sami Ashkheli. SolidWorks and Creo are the same tools, but some uniqueness lies like powerful tool, simple to learn, easy to learn, and a live community with the SolidWorks make your skills enhance. So with Creo, actually, I personally experienced the software. You cannot get the support, but with the SolidWorks, there is a lot of community, lot of the tutorials and the platform even SolidWorks itself support you on your specific queries. The next question from Kutub Ali Shah. Apart from design, is this SolidWorks state dynamic and static analysis of the components? Yes. Within SolidWorks, you can perform both static, dynamic, linear, and non-linear analysis. Even SolidWorks has simulations tools for the flow simulations. You can test the airflow within the SolidWorks. It has also include a plastic model for mold designing, which help you to design your mold and perform simulations to define the runners and what sort of PC specification are required for best performance software? For that, you can directly visit to the SolidWorks website, and there you can get the information. Can you ask, please? Can you please tell me its pure application in power sector, uh, electrical electrical engineering with power as major subject, in transmission line, grid design, etc. Yes, SolidWorks is complete electromechanical solution application with power sector or circuit design and schematic drawings, switch gear design and integration of cable, harness and mechanical structure. Also PCB design, electronics and overall power housing design include structures as well. The next question asked by engineer Heather Ali, what is use of SolidWorks in building? SolidWorks, as I already informed that SolidWorks has structural tools as well that you can design your building structures within the SolidWorks and can complete them within it. So I think we are almost done with the question. Uh, let me let me share my mic with Miss Mehak.
अस्सलाम वालेकुम। आपको स्क्रीन पे नजर आ रहे हैं, ये हमारे फ्यूचर में कंडक्ट होने वाले हैं कुछ कोर्सेज जो इसी पैटर्न पे चलेंगे। सबसे पहले आएगा एडवांस पार्ट मॉडलिंग, फिर असेंबली मॉडलिंग, ड्राइंग्स, सरफेस मॉडलिंग, कैम स्टैंडर्ड, मोल्ड डिजाइन, शीट मेटल, रिवर्स इंजीनियरिंग, सिमुलेशन एंड 3D इंस्पेक्शन। ये वर्कशॉप की सीरीज हम स्टार्ट करने लगे हैं, तो ये उसका फर्स्ट वेबिनार था। और सीपीटी के हवाले से आपके काफ़ी क्वेश्चंस आ रहे थे। उसमें पहला तो ये कि वेबिनार इज फ्री टू अटेंड, आप इसको फ्रीली अटेंड कर सकते हैं। हमने वेबिनार पे फीस ही रखी है। और सीपीटी पॉइंट्स अगर आप अवेल करना चाहते हैं तो आप को ईमेल आया होगा, उसमें व्हाट्सएप नंबर शेयर है, आप उस पर इजी पैसा अमाउंट 500 आप उसको डिपॉजिट करेंगे और मुझे स्क्रीनशॉट अपना पीसी नंबर के साथ मैसेज कर दीजिएगा विद वेबिनार्स नेम, क्योंकि हमारे अपकमिंग वीक्स में हर वीक के गैप के साथ काफ़ी वेबिनार्स आने वाले हैं, तो कंफ्यूजन क्रिएट ना हो तो उससे काइंडली आप मुझे अपना वेबिनार नेम और साथ व्हाट्सएप कर दीजिएगा। अगर आपकी अभी कोई क्यूरीज हैं तो नंबर आपको ईमेल में मेंशन है, और आईडी ईमेल आईडी है qswebinar@qualitysolutions.pk। कोई आपकी अगर क्वेरी है तो आप काइंडली उसमें मुझे ईमेल कर सकते हैं। थैंक यू। सीपीडी पॉइंट की अलॉटमेंट के हवाले से भी काफ़ी क्यूरीज थी जो आई थी। उसके हाथ से ईमेल के जरिए आपको सर्टिफिकेट आ जाएगा, साथ ही जो लिस्ट है वो फॉरवर्ड कर दी जाती है पीईसी को। तो आप जब सीपीडी पॉइंट्स अपना क्लेम करने जाएंगे तो वो आपके जो सीरियल नंबर सर्टिफिकेट पे लिखा होता है वो उसके साथ वेरीफाई करेंगे, जो लिस्ट हमने उनको फॉरवर्ड की दी है उस लिस्ट के साथ वो वेरीफाई करेंगे और आपको पॉइंट्स अलॉट हो जाएंगे। If you have any questions, kindly type it in the question answers tab. You have 5 minutes. After that, we will end this webinar. Thank you.
And if we do not answer you right now, so we will note your question and reply you via email. So thank you so much for your time. We are almost done with our session. Have a great day.
आई थिंक सारी क्वेरीज खत्म हो गई हैं। नेक्स्ट वीक हमारा वेबिनार जो सीरीज के मुताबिक है वो है कैंप पर, तो उसकी रजिस्ट्रेशन कल से ऑन पीसी की वेबसाइट पे अपलोड हो जाएंगी, आप वहाँ से चेक कर सकते हैं। तो आज के लिए अल्लाह हाफ़िज़।